Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P2245 refers to the air-fuel ratio AF sensor, specifically its V-cent circuit experiencing low voltage. This error indicates that the voltage signal generated by the AF sensor, which is critical for maintaining the correct air-fuel mixture, has dropped below a predetermined threshold. The powertrain control module, PCM, monitors this sensor to ensure efficient engine performance while minimizing emissions. The AF sensor, sensor 1, is typically located in the exhaust system before the catalytic converter. It plays a vital role by measuring the amount of oxygen in the exhaust gases, which allows the PCM to adjust fuel injection and air intake accordingly. If the PCM detects that the output voltage from this sensor is lower than expected, it prompts the storage of this DTC, which can lead to performance issues if not addressed promptly. The AF sensor, also known as lambda sensor, is integral to monitoring the composition of exhaust gases. Specifically, it measures the concentration of oxygen, allowing the PCM to adjust fuel delivery to optimize combustion. In the context of DTC P2245, the term V-cent refers to the voltage signal from this sensor, which is expected to provide feedback about air-fuel mixture efficiency. If the output voltage from the AF sensor, sensor 1, falls below the specification, indicating low voltage, it triggers this diagnostic code. The PCM, or powertrain control module, is responsible for the overall behavior of the engine control system, and thus reacts to faults by storing codes like P2245. The sensor is typically located in the exhaust manifold, or pre-catalytic converter zone, where it can effectively measure oxygen levels. This placement is crucial for the early detection of fuel mixture imbalances, ensuring both optimal performance and minimal emissions. When diagnosing DTC P2245, several potential causes should be considered. The first possibility is a shorted V-cent wire, which means the circuit may have come into contact with ground or another wire, causing incorrect voltage readings. This would prevent the AF sensor from providing an accurate signal to the PCM. Another potential cause is a faulty PCM. If the PCM itself is malfunctioning, it may misinterpret the signals from the AF sensor, leading to erroneous code storage and impaired engine performance. Finally, a defective AF sensor could be the root cause. If the sensor fails to operate correctly, it will not provide the necessary feedback to the PCM, thereby triggering the low voltage fault. Thus, thorough testing of these components is essential to pinpoint the actual cause of the issue. The impact of DTC P2245 manifests through several noticeable symptoms. The most immediate sign is the illumination of the check engine light on the dashboard, alerting the driver to a potential issue requiring attention. Often, this code correlates with poor fuel economy, as a malfunctioning AF sensor may lead to improper fuel mixture settings, resulting in inefficient combustion. Another common symptom is a rough engine idle, where the vehicle may experience inconsistent or unstable idling speeds, indicating the engine is struggling to maintain smooth operations. Additionally, you may observe increased emissions, as a miscalibrated air-fuel mixture can lead to unburned fuel, impacting environmental compliance. Awareness of these symptoms can help drivers identify the need for timely diagnostic checks and repairs. The first step in troubleshooting DTC P2245 involves starting the engine and maintaining the speed at 3,000 RPM without load, either in park or neutral position. This procedure is crucial because it allows the PCM to monitor the operation of the AF sensor effectively under controlled conditions. Holding the engine at this speed will also engage the radiator fan, a condition that simulates a typical operating environment. Once the fan activates, the engine can then be allowed to idle. This process is designed to confirm the normal operation of the AF sensor and the associated circuitry, establishing a baseline observation. If the DTC persists following this step, further inspection of the external circuit may be necessary. In the second step of our troubleshooting process for DTC P2245, focus shifts to inspecting the V-cent wire for any signs of being shorted. Before disconnecting any connectors, it's essential to jump the SCS, or Service Check Switch line, using the Honda Diagnostic System HDS tool for diagnostics. This should be done with the engine off while waiting for more than 1 minute to ensure proper conditions for testing. At this point, disconnect the AF sensor, Sensor 1 connector and the PCM connector B. This step prepares the system for a detailed inspection. Inspect the V-cent circuit by using the open shorted wire inspection description as a guideline. This investigation should lead to checking if the V-cent has shorted to ground, and if so, the reading should indicate greater than 1 MAO. A low resistance reading implies an electrical short exists, which could affect sensor performance and must be resolved. The third step in troubleshooting DTC P2245 involves verifying the output voltage of the AF sensor, Sensor 1, while in operation. It's essential to reconnect the AF sensor connector, ensuring a secure connection. Once this is complete, the next task is to put the vehicle in the ignition mode, which means turning the key to on without starting the engine. However, in this context, the engine should be running. This process will allow us to measure the sensor's output voltage during its normal function. According to diagnostic protocols, the output voltage should ideally be at least 0.2 volts or higher when the engine is running. If the output voltage is found to be below this threshold, it suggests a potential issue with the PCM or the AF sensor itself. Document these voltage levels accurately to guide future diagnostic steps. The final step in the troubleshooting guide for DTC P2245 centers around the AF sensor, Sensor 1. After confirming that the previous steps have indicated no faults in the external circuit or PCM, the likelihood of the AF sensor being the cause of the problem increases. This step requires a thorough inspection to assess whether the sensor itself is faulty. If 2 previous inspections yielded normal results, it is reasonable to conclude that issues lie within the AF sensor. The defective sensor will not provide accurate voltage readings, ultimately leading to diagnostic codes such as P2245. To confirm the diagnosis, consider replacing the sensor or conducting further specialized tests if required. This systematic approach is designed to narrow down the fault effectively, ensuring that repairs made are both necessary and effective. After completing the critical repairs for DTC P2245, the next step involves verifying that the issue has been resolved satisfactorily. Begin by clearing the DTC from the Powertrain Control Module, PCM. This facilitates the resetting of the engine management system and allows the vehicle to run without the immediate influence of the previously stored fault. Subsequently, an essential step is to test drive the vehicle in a manner that replicates everyday driving conditions, paying close attention to engine performance, particularly during various speeds and RPM ranges. Monitoring the check engine light during this period is crucial, as it should remain off if the repairs have effectively resolved the faults. Additionally, Continued assessment of fuel efficiency and engine responsiveness will offer further confirmation that the system has returned to its normal operating condition. To mitigate the risk of encountering DTC P2245 in the future, implementing preventive maintenance measures is highly recommended. One crucial practice is to regularly inspect the AF sensor connections and wiring for any signs of wear, corrosion, or damage. Performing these checks can ensure that any compromised connections are repaired promptly, preventing electrical shorts that may lead to low-voltage errors. Furthermore, keeping the exhaust system clean is essential. Accumulated carbon buildup and debris can affect sensor readings and overall performance. Adopting a proactive stance on maintenance not only extends the life of the AF sensor and associated components, but also ensures that the vehicle operates efficiently, minimizing both emissions and fuel consumption. In conclusion, DTC P2245 signifies a low-voltage signal from the AF sensor, Sensor 1, which holds significant implications for engine performance and efficiency. Understanding the role of this sensor in monitoring air-fuel ratios is essential for diagnosing performance issues effectively. By following the systematic troubleshooting steps outlined, technicians can pinpoint the specific cause of the fault, be it a wiring issue, PCM malfunction, or sensor failure. Lastly, adopting preventive maintenance practices can greatly reduce the likelihood of facing DTC P2245 in the future. This comprehensive approach of diagnosis, repair, and maintenance not only ensures optimal vehicle performance, but also contributes to the longer lifespan of engine components. Please like and subscribe to the channel. See you next time!